Microsoft released Windows XP in October 2001. XP was codenamed Whistler during its development. It became a huge success for the company. Users liked its stability and improved user interface. XP combined the consumer-focused Windows 9 X line with the business-oriented Windows NT line. This unification was a major step forward. Many people use Windows XP for a very long time. It set a high bar for future Windows versions. The pressure was on for Microsoft to deliver something even better next. After Whistler, Microsoft had big plans. The next major revolutionary version of Windows was codenamed Blackcomb. Blackcomb was envisioned as a far future operating system. It was supposed to include groundbreaking technologies. These included a new file system and advanced ways for applications to work together. Blackcomb was the long-term dream. It was many years away from becoming a reality. Microsoft knew it needed something to release before Blackcomb was ready. This interim release would bridge the gap. This interim operating system was codenamed Longhorn. The name Longhorn, like Whistler and Blackcomb, came from a ski resort in British Columbia, Canada. Initially, Longhorn was planned as a minor release. It was meant to refresh Windows XP and keep customers engaged. It would introduce some new features, but it was not supposed to be as ambitious as Blackcomb. The idea was to get it out relatively quickly. This would give users new capabilities while Microsoft worked on the bigger Blackcomb project. Longhorn was first discussed publicly in 2001. Early concepts showed a desire to innovate. The plan was to build upon the solid foundation of Windows XP. Microsoft wanted to explore new user interface ideas. They also aimed to improve how users manage their data. Even as an interim release, Longhorn started to generate excitement. Developers and tech enthusiasts were curious about what Microsoft would do next. The journey of Longhorn, which would eventually become Windows Vista, was just beginning. It would prove to be a much longer and more complex journey than anyone initially imagined. Development on Longhorn began in earnest in late 2001. This was right after Windows XP hit the shelves. The initial team was optimistic. They believed they could deliver Longhorn fairly quickly. The target release timeframe was somewhere around 2003. This would have been a typical 2-year cycle after XP. Microsoft wanted to maintain momentum. A 2003 release would keep Windows fresh and exciting. It would also provide a platform for new hardware and software. Early demonstrations of Longhorn showed off some interesting ideas. Microsoft was experimenting with new user interface concepts. One such concept was codenamed Plex. Plex aimed to provide a cleaner, more modern look than XP's Luna interface. Another UI idea was Slate, which was designed for a more task-oriented approach. These early designs were visually appealing. They suggested a significant evolution in how users would interact with Windows. The focus was on making the desktop experience more intuitive and powerful. The expectations for Longhorn were quite high from the start. Windows XP was a massive success, so people naturally expected Longhorn to be even better. Microsoft itself fueled these expectations with its early previews and talks. They promised a more connected and seamless computing experience. The plan was to include features that would make it easier to find information. They also wanted to improve how applications shared data. This early vision was compelling. It painted a picture of a smarter, more user-friendly operating system. However, this initial 2003 target would prove to be far too ambitious. The scope of Longhorn began to expand rapidly. What started as a minor release soon took on a life of its own. The team started to incorporate more complex features. Some of these were originally intended for the later Blackcomb release. This feature creep would become a major challenge. It would ultimately lead to significant delays. The dream of a quick 2003 release slowly faded away as Longhorn's complexity grew. One of the biggest reasons for Longhorn's expanding scope was feature assimilation. Microsoft decided to pull in several ambitious technologies originally planned for Blackcomb. This decision dramatically changed Longhorn's trajectory. It was no longer a simple update to Windows XP. Instead, it became a vehicle for delivering next-generation platform capabilities. This shift in strategy was driven by a desire to innovate quickly, but it also introduced enormous technical challenges for the development team. The project's complexity began to spiral. A prime example of this ambition was WinFS, short for Windows Future Storage. WinFS was envisioned as a revolutionary new file system. It was based on relational database technology. The goal was to allow users to find and organize their files in much more powerful ways. You could search for documents, emails, and photos based on their content and relationships, not just by their names or locations. WinFS was a core pillar of the original Longhorn vision. It promised to change data management fundamentally. However, building it proved to be incredibly difficult. Alongside WinFS, Longhorn was also set to introduce two other major pillars. These were Avalon and Indigo. Avalon was the code name for what later became Windows Presentation Foundation, WPF. It was a new graphics subsystem and UI framework. Avalon aimed to enable richer, more interactive application interfaces. Indigo, later Windows Communication Foundation, WCF, was a new communications subsystem. It was designed to simplify the development of connected applications and web services. These were powerful but also very complex technologies to integrate into the OS. The combination of WinFS, Avalon, and Indigo made Longhorn a massive undertaking. Each of these pillars was a huge project in itself. Trying to develop all of them simultaneously while also building a new operating system was a monumental task. The Longhorn team was essentially trying to reinvent core parts of Windows. This feature frenzy led to an increasingly bloated and unstable codebase. Progress slowed down, deadlines were missed. It became clear that the original plans were simply too ambitious to deliver in a reasonable time frame. The early 2000s were a turbulent time for computer security. Malicious software like the Blaster and Sasa worms caused widespread disruption. These attacks exploited vulnerabilities in Windows operating systems. They affected millions of computers worldwide. The scale and impact of these incidents were a huge wake-up call for Microsoft. It highlighted critical weaknesses in their software. The company faced intense criticism for not doing enough to protect its users. This security crisis directly impacted Longhorn's development. In response to these threats, Microsoft launched its Trustworthy Computing Initiative in 2002. Bill Gates himself emphasized that security, privacy, and reliability had to become top priorities. This initiative had profound implications across the company. For the Windows division, it meant a significant shift in focus. Developers working on Longhorn had to divert their attention. They needed to conduct extensive security reviews of existing code. They also had to design new security features from the ground up. This was a necessary but time-consuming diversion. The Trustworthy Computing Initiative meant that Longhorn needed to be fundamentally more secure than its predecessors. This wasn't just about patching holes, it was about re-architecting parts of the operating system. Features like a built-in firewall, improved protection against malware, and secure startup processes became critical. User account control, UAC, though controversial later, was conceived during this period. The goal was to limit the ability of malicious software to damage the system. These security enhancements added another layer of complexity to the already ambitious Longhorn project. This new emphasis on security, while essential, further complicated Longhorn's development. Resources were shifted, schedules were revised. Features that were not directly related to security sometimes took a back seat. The team had to balance the desire for innovative new features with the urgent need for a more secure platform. This balancing act was difficult. It contributed to the ongoing delays and the growing sense that Longhorn was struggling to meet its goals. The journey to Windows Vista was becoming increasingly challenging. Microsoft realized that a major change was needed. Section 5. The infamous reset, starting over with Longhorn in 2004. By mid-2004, it was painfully clear that the Longhorn project was in trouble. The code base, built on Windows XP and burdened with half-finished ambitious features, was unstable. Development progress had slowed to a crawl. Integrating WinFS, Avalon, and Indigo simultaneously proved to be a nightmare. Microsoft executives realized that Longhorn, in its current state, might never ship. A drastic decision was needed to save the project. This led to what is now famously known as the Longhorn reset. It was a pivotal moment in Windows history. In August 2004, Microsoft announced internally that they were essentially starting over with Longhorn. Instead of trying to fix the existing problematic code base, they would take a different approach. The new plan was to rebuild Longhorn on a more stable and modern foundation. This foundation would be the code base of Windows Server 2003 Service Pack 1. Windows Server 2003 was known for its robustness and security improvements. This shift provided a much cleaner slate for Longhorn's development to proceed. The reset meant that many of the ambitious features planned for Longhorn had to be re-evaluated. The most significant casualty was the deep integration of WinFS. While WinFS technology would continue to be developed separately, it would not be part of the Longhorn operating system release. This was a major disappointment for many. However, it was a necessary sacrifice to make Longhorn a shippable product. Other features were also scaled back or postponed. The focus shifted to delivering a more reliable and secure OS. Adopting the Windows Server 2003 SP1 codebase brought immediate benefits. It provided a more secure and stable starting point. It also included many architectural improvements made since Windows XP. This allowed the Longhorn team to focus on building the new user experience and key platform features. While the reset was a difficult and costly decision, it was crucial. It put Longhorn back on a path towards eventual release as Windows Vista. The dream of a revolutionary OS was tempered by the practical need to deliver. Section 6, Longhorn Reborn, a new foundation, a sharper focus. After the 2004 reset, the Longhorn project, now officially heading towards becoming Windows Vista, entered a new phase. The development team embraced the Windows Server 2003 SP1 codebase. This provided a more disciplined and structured environment. The anything-goes atmosphere of the early Longhorn years was replaced. There was a renewed emphasis on engineering best practices. Microsoft was determined to avoid the mistakes of the past. This meant more rigorous code reviews and testing cycles. With the new foundation, Microsoft re-evaluated Longhorn's feature set. The grand vision of WinFS being integral to the OS was shelved for Vista. However, key technologies like Avalon, which is the Windows Presentation Foundation, and Indigo, known as the Windows Communication Foundation, remained. These were crucial for enabling next-generation applications. The user interface, which would become known as Windows Aero, also continued development. Aero aimed for a visually rich experience with translucent window borders and smooth animations. The focus was now on delivering these core elements well. The reset also led to a more modular design approach for Windows. Components were developed to be more independent of each other. This made the system easier to build, test, and service. It also helped improve stability. If one component had an issue, it was less likely to bring down the entire operating system. This architectural change was a significant step forward. It laid important groundwork for future versions of Windows as well. The reborn Longhorn was being built with greater care and precision. Security remained a top priority in the post-reset development. The lessons from the Trustworthy Computing Initiative were deeply ingrained. Features like user account control, BitLocker drive encryption, and Windows Defender, which is anti-spyware, were central to Vista's design. The goal was to make Vista the most secure version of Windows ever released. While this focus was commendable, some of these security measures, particularly UAC, would later face criticism for their implementation. Nevertheless, the commitment to security was undeniable in the rebuilt Longhorn. Section 7, Inviting the World Beta Tests and the Voice of the Community. Microsoft began wider testing of the new Longhorn in mid-2005. The first official beta, known as Longhorn Beta 1, was released on July 27, 2005. This was a significant milestone. It was the first time a large number of developers and IT professionals could get their hands on the post-reset code. Beta 1 showcased the new Windows Aero user interface. It also included early versions of key features. The feedback from this initial beta was crucial for shaping the final product. Microsoft relied heavily on community involvement during Vista's development. The customer preview program allowed many enthusiasts and technical users to participate in testing. Microsoft also ran the Technology Adoption Program with key business customers and partners. These programs provided invaluable real-world feedback, Testers reported bugs, suggested improvements, and highlighted compatibility issues. Microsoft used this data to refine features and fix problems. This collaborative approach was essential for an operating system of Vista's complexity. Following Beta 1, Microsoft released several interim builds and a more feature-complete Beta 2 in May 2006. Beta 2 was a major step towards the final product. It was made available to a much larger audience. This included millions of public testers through the customer preview program. Beta 2 gave a clearer picture of what Windows Vista would look like and how it would function. It included many of the end-user features. It also allowed hardware and software vendors to finalize their driver and application compatibility work. The beta testing process continued with release candidate versions. RC1 was released in September 2006, followed by RC2 in October. These builds were very close to the final version of Vista. The focus during the release candidate phase was on fixing remaining bugs and ensuring stability and performance. The feedback from testers during this period was critical for polishing the operating system. Microsoft actively listened to the community. They made numerous changes based on this input. The extensive beta program aimed to make Windows Vista as solid as possible for its launch. Section 8. Crossing the finish line. Vista's arrival and official launch. After years of development, resets, and extensive beta testing, Windows Vista was finally ready. On November 8, 2006, Microsoft announced that Windows Vista had reached the release-to-manufacturing milestone. This meant that the core development work was complete. The final code was signed off. This RTM build was then provided to computer manufacturers. They could begin installing Vista on new PCs. It was a moment of relief and accomplishment for the Windows team. Reaching RTM is a critical step for any operating system. It signifies that the product is deemed stable and ready for mass distribution. For Windows Vista, this RTM build was version 6.0.6000. Following the RTM announcement, Microsoft began rolling out Vista to its volume license customers. These are typically large businesses and organizations. They received access to Vista starting November 30th, 2006. This allowed them to begin their deployment, planning, and testing before the general public release. The worldwide consumer launch of Windows Vista took place a few months later. On January 30th, 2007, Windows Vista became available for purchase in retail stores. It was also pre-installed on new computers from major manufacturers. Microsoft organized launch events around the globe to celebrate the release. There was significant marketing hype. Vista was positioned as a major leap forward in personal computing. It promised enhanced security, a stunning new look, and powerful new capabilities for users. The launch marked the end of one of Microsoft's longest and most challenging development cycles. The journey from the initial Longhorn concepts in 2001 to the Vista retail release in 2007 was epic. It was filled with ambition, setbacks, and ultimately perseverance. Windows Vista was finally out in the world. Now it was up to users to decide whether the long wait had been worth it. The initial reception would soon reveal the next chapter in Vista's story. Section 9. Vista's verdict. A contested legacy and lessons learned. Windows. Vista's reception upon launch was decidedly mixed. While some users and reviewers praised its new visual interface Windows Aero and its improved security features, many others encountered significant problems. One of the most common complaints was about performance. Vista demanded much more powerful hardware than Windows XP. Many existing computers struggled to run it smoothly. This led to frustration for users upgrading older machines. Even new Vista-capable PCs sometimes felt sluggish. Another major point of contention was user account control. UAC was designed to improve security by prompting users for permission before making system-level changes. While well-intentioned, its implementation was often seen as overly intrusive. Users were frequently bombarded with prompts, leading to prompt fatigue. Many found UAC annoying and chose to disable it, potentially compromising their security. Software and hardware compatibility was also a significant issue. Many older programs and peripherals did not work correctly with Vista at launch. Despite these criticisms, Windows Vista did introduce several important advancements. Its security architecture was a significant improvement over Windows XP. Features like BitLocker drive encryption, address space layout randomization, and improved malware protection made Vista a more robust platform. The Windows Display Driver model enabled the Aero interface and improved graphics stability. Technologies like Superfetch and ReadyBoost aimed to improve system responsiveness. Many of these underlying improvements were valuable and carried forward. Ultimately, Windows Vista's legacy is complex. It's often remembered as a commercial disappointment compared to Windows XP and its successor, Windows 7. However, Vista played a crucial role in modernizing the Windows platform. Many of the tough lessons learned during Vista's development directly informed the creation of Windows 7. Windows 7, built upon Vista's core architecture, refined its features and addressed many of its shortcomings. In this sense, Windows Vista, despite its troubled journey and mixed reception, was a necessary stepping stone for the future of Windows.